Hey all, so we are going to do our last notes of semester one. So exciting, so thrilling. So you are wanting to get yourself ready for these. We're going to do our first section of notes from 4.4. This is a little bit longer set of notes, and so I'm not going to necessarily go through every problem individually. If you want to see some of the more challenging problems, I strongly encourage you to look at the PDF that's also attached. I just don't want this video to be 17 hours long, so I'm going to jump around through a couple of steps. Now, let's get ourselves ready for notes, and we're going to begin. Number 1, 3x to the x plus 2 is equal to 27. So what is going to happen here is that we don't actually need a calculator for this problem. You will for most of the others. So if you don't have your graphic calculator, pause, go get it. However, there are going to be some that you don't need it for. For example, we have a base 3 here and 27. So what we're going to want to do is use that same base. So 3 to the x plus 2 is equal to 3 to the third. Now we don't need these, they cancel out because the same thing is happening to both sides. So then x plus 2 is equal to 3, subtract x equals 1. This is just fine without a calculator. However, what if it's not 27, it's just 7? We can't, without a calculator, write 7 in terms of 3. So what we are going to want to do is we want to use a logarithm. And I saw some of you jumping ahead of yourselves and using this already from previous lessons. Now, since you're on a calculator, you want to either use log or you want to use ln because these are the ones that are actually buttons on your calculator. I will always use ln. You will get the same answer either way. I will tell you this now. Every single professional mathematician and scientist uses the natural log, not the log unless it's a specific problem in base 10 or scientific notation. Everyone uses ln. It's going to be consistent for the rest of your life that you are in math and science classes. I recommend that you just get used to it. It's fine. It's helpful. It's great. It's a lot easier to do calculus with, and since this is a pre-calculus class, we are going to use natural log. So the first thing that we're going to do is take the log of both sides. So ln of both sides, and you end up with ln of 3 to the x plus 2 is equal to ln of 7. And this is why we do this, is then the exponent comes down in front using our log rules from previous lessons. Make sure you use parentheses here. X plus 2 times ln of 3 is equal to ln of 7. And so what this tells us is that x plus 2 is equal to ln of 7 over ln of 3. This is something you can just type into your calculator as ln of 7 over ln of 3. And you'll get a lovely decimal. X plus 2 is equal to 1.771. And when you subtract 2, you end up with x is equal to negative 0.229. Always go to 3 decimal places unless instructed otherwise. Now, here's one that I'm not going to go through completely, but what's really important here is that here's our exponential term. The goal needs to be to get this alone first before you take the log. So in this case, you must subtract the 7 over, and e to the 2x is equal to 6. Now you can do the log of both sides and solve from there. So exponential term by itself before you take the log. Now sometimes you're going to see multiple exponential terms. Now what's nice about this is that there are 1, 2, 3 of them, and that e to the x and e to the 2x, you can treat this like a quadratic. And we're just going to say e to the x is the same as x here. You solve it just by factoring. So x minus 8, x plus 7 is equal to 0. So x is minus 8 equals 0, or x plus 7 equals 0. But now you'll remember here is we're not dealing with x, we're dealing with e to the x. So the equations I actually want to solve are e to the x minus 8 equals 0, which is e to the x equals 8, which you can solve using your calculator. X is equal to ln of 8. Or e to the x plus 7 is equal to 0. You end up with e to the x is equal to negative 7, and this is important because this does not exist. You can't have a exponential equal to a negative, especially when you have a base that is positive. E is a positive number that's approximately 3. Lastly, you might be asked to solve word problems. So here we have $5,000 is invested at 5% interest, compounded quarterly. How long will it take for the investment to double in value? Well, we're talking about compound interest and doubling. So if t is equal to 2 times 5,000, which is equal to the compound interest formula, 5,000 times 1 plus 5% interest over compounded quarterly 4, and then 4 to the t, because time is the one we don't know. So then, again, we want the exponential term alone first. So I'm going to divide by 5,000 on both sides and end up with 2 is equal to 1, and I'm going to simplify what's inside there to 1.0125 to the 4t. And now is when I'll take the log of both sides and bring down the exponent. So 4t times ln of 1.0125. From here, you can solve for t, and then remember your unit is in years. Hopefully this video didn't go on too long, and if you have any questions about any of the problems here, please look at the PDF, and if you are interested in more in-depth explanation, just send me an email, leave something in comments, or set up a Zoom appointment. Talk to you all later.